Okay, so we are looking at a linear system, which is formed when you compare two or more linear relations. Okay? So if we have one linear equation and then another linear equation and you compare the two of them, that's called a linear system. Okay? When you compare two of them, and we've done this before, so for example, they gave you a little graph here. This is one linear equation, and this is another linear equation. What we're doing today is we're looking for the, what is this called? The point of intersection. It's just what it sounds like. The point where the two lines intersect, where they meet. If you want to write that word on your paper. The point of intersection is the point where two linear relations meet. And that point is the solution. It's the answer to the question. Okay, so we have two people that are charging for babysitting. So Elsa is charging $4 per child. We're going to be coming up with an equation to represent this. So I want you to think about it for a second. That's Elsa's rate. And Tan is charging a $10 administrative fee plus $2 per child. Right now, I want you to come up with the equation for Elsa and the equation for Tan. How would you represent the cost that Elsa charges? Remember, the cost is related to what? How does the cost change? What are they charging for? They're not charging per hour. Read the question. Okay, so we're looking at a relationship between cost that they're charging, how much it costs for someone to use Elsa, and how many, based on how many children they have to babysit. So what would be the equation for Elsa? C equals 4n. Excellent. What does n stand for? Number of children. Beautiful. Okay, somebody else for Tan. Okay, so Tan would be 10 plus 2n. Excellent. If you hire Tan and you have no children, how much do you have to pay her? $10. Which one is direct and which one's partial? Yes.
Elsa.
I am asking choice. Elsa is excellent.
And Tan's partial.
Excellent. We know that Elsa's is going to start where?
At 4.
The origin.
0.
No children, you pay nothing. Every time you have an extra child that you have to get babysitting for, you have to pay an extra $4. So it's going to go up by 4 every time.
That one starts at 10.
And this one starts at 10, excellent, and would go up by what every time? 2. So they're both going to be linear, but one of them's direct and one of them's partial. What you're going to do right now is you're going to graph them separately. Okay, so first things first, you have to figure out how to set up your graph. Which variable is going to go on the x-axis, the number of children or the cost? Number of children, because that is independent. The cost depends on how many children you have. Okay, so we're going to pick a scale. What's a good scale to count by for children? Ones? 1, 2, 3, 4. Okay, so I'm going to use blue for Elsa. We already talked about this. Elsa's direct. She starts at 0, 0. Every time she adds a child, she charges $4. So 2 kids is $8. We're going up by 4 every time. 4, 8, 12, and so on. Okay, so once you figured out the coordinates, we can connect the line. This represents Elsa. Hello? Hi. She didn't go today. Sorry. Okay, so what is the point of intersection? I need you to graph both of them and circle a point and label it. What is the point of intersection? Excellent. So what is the point? It's not 24. It is not 24. Let me speak. Okay, so here's the question. Look at your paper. Did you identify the point of intersection? Skip the page. We're going to answer this together. Number 2. Arsima, can you read number 2, please? Shh. Okay. You're going to have a question. You're going to have a question like this on your test. You're going to have probably 2 questions, maybe 3 or 4 questions like this on each way out. They always ask this. The question says, here's 5 children. We said more than 5 children, 10 is cheaper. Less than 5 children, who is lower on the graph? Elsa. Okay?